All right, so yesterday we talked about what a sequence was. We talked about naming term numbers, finding specific terms. Now again, starting tomorrow, we're going to start with arithmetic, however you want to say it, 13.2, and then 13.3 is geometric. There's specific rules for everything with that. We're going to find the partial sums of each of those sequences, arithmetic and geometric, and there's specific formulas. But if you're just asked to find the partial sum of a random sequence, you don't know if it's arithmetic, geometric, whatever, this is what you're doing. First of all, what does the word sum mean? The answer to when you do what? When you add, okay? So finding the partial sum. If they want the first four, the partial sum of the first four, what you're doing is you're adding together. So in this case, whatever the rule is, you would plug in 1, you'd plug in 2, you'd plug in 3, you'd plug in 4, and you'd add them all together. All right, I'll show you what that means in a second. There are specific formulas for this when we do, like I said, arithmetic and geometric, and we'll get to that later on this week and next week. But here, we're going to just use our calculator stuff down. So if they want the first partial sum, the second partial sum, and so on, you plug in whatever term numbers you're talking about, and you add them all together. So if they want the fifth partial sum, you would plug in 1, 2, 3, 4, and 5, and add them all together. All right, that's the sequence of partial sums. So if you had something like this, it says the first 4 partial sums, right? Everybody with me? So if I want the first 4, that means I'm going to plug in 1, 2, 3, and 4. So I'm going to find a sub 1. What is a sub 1? What does that mean? 1 over 2 to the first power, which is what? 1 over 2, okay? So now I'm going to find the second partial sum. So I take 1 over 2 to the first power plus 1 over 2 to the second power. Does that make sense? So now we're going to add this together. So I have 1/2 plus 1/4. Agreed? What do I have to do here? Common denominator. So my common denominator between 2 and 4 would be 4. So if I change this to a 4, this becomes a 2. You guys agree? So my answer here would be 3 over 4. Good. So if I'm going to find the third partial sum, what am I going to plug in? 1, 2, and 3 and add them together. So 1 over 2 to the first plus 1 over 2 to the second plus, God bless you, 1 over 2 to the third. Now, I need to see this, guys. I need to see what you're doing, not just what you get in your calculator. So if we simplify this, it's 1 over 2 plus 1 over 4 plus 1 over 8, correct? What's your common denominator between 2, 4, and 8? 8. If I change this to an 8, I had to multiply 2 times 4. So if I multiply the bottom by 4, I multiply the top by 4, correct? This becomes 4. And if I change this to an 8, I would have to multiply 4 by 2. If I multiply the bottom by 2, then I multiply the top by 2. So my denominator stays the same. And what is 4 plus 2 plus 1? 7. Good. And then to find the fourth partial sum, I'm going to plug in which numbers? 1, 2, 3, and so 1 over 2 to the first plus 1 over 2 to the second plus 1 over 2 to the third plus 1 over 2 to the fourth. Does that make sense? So if we're going to simplify this, I'll do it underneath. I have 1/2 plus 1/4 plus 1/8 plus 1/16. What's the common denominator between all 4 of those? 16. Good. So if I'm going to change 2 to 16, I'd have to multiply the bottom by 8. If I multiply the bottom by 8, I multiply the top by 8. To change 4 to 16, I multiply by what? 4. So if I multiply the bottom by 4, then I multiply the top by 4. The next one, if I change 8 to 16, I multiply by 2. So if I multiply the bottom by 2, then I multiply the top. And do I have to change the last denominator? So my denominator is 16. What's 8 plus 4 plus 2 plus 1? 15. And that's your first 4 partial sum, however you want to say it. Does that make sense? Okay, so whatever one you're looking for, say they want the fifth, you would do 1 over 2 to the first plus 1 over 2 to the second plus 1 over 2, all the way up to the number that they're asking for. Comprende? All right, now I'm going to talk about, oh my gosh, summation notation, sigma notation. This looks much harder than it is. First of all, this is sigma. It's a Greek letter. Like I said yesterday, you guys will be familiar with that when you get to college. See in everybody's cars, all their Greek letters. We're going to talk about this being the lower number on the bottom and this being the upper. We're going to talk more about this later. This is the expression you're going to use to evaluate. Expression used to evaluate. All right, this is summation notation. We're going to do basic today, and then we're going to use formulas for the next 2 lessons. All right, index of a summation tells us to end with k equals n. This tells us to add. Our sigma is telling us that we're going to add. This number tells us what to start with. When I say upper and lower, the number on the bottom is what you start plugging in. The number on the top is what you end plugging in. You'll see what I mean in a second. So this is what number you start plugging in with, and this is what number you end with. Okay, very important. Let's do these, and then this is it. We're done. All right, so let's look at A. All right, tell me how to do A. Everybody go. You guys are like, what? What? All right, let me show you how easy this is. I told you yesterday this was super duper easy. It's just when you first look at it, you're like, I have no idea what this means. What number do they want me to start evaluating with? 1. And what number do they want me to end with? 5. So I'm going to plug in 1. I'm going to plug in 2. I'm going to plug in 3. I'm going to plug in 4. And I'm going to plug in 5. And to find the sum, what do you do with all of your answers? You add them together. So this is how you guys would do this. You would say, okay, well, I'm evaluating using k squared. So I'm going to plug in 1. What's 1 squared? 1. Then I'm going to plug in what number? 2. So 2 squared is 4. Then I'm going to plug in what number? 3. 3 squared is 9. Then I'm going to plug in what number? 4 squared is perfect. Then I'm going to plug in what number? And 5 squared is 25. Now to find the sum of those numbers, what do you do? Add. So somebody add that for me. This is 14, right? 14 and 16 is 30. So 55. Okay, so your answer here would be 55. Now that I explained it, is this a very hard concept? No. You see this as sigma notation. You say, oh, okay, this is sigma notation. This means I'm going to add. So with letter B, what number do they want me to start plugging in and evaluating? 3. And what do they want me to stop at? So I'm going to plug in 3, 4, and 5. And then I do what with those numbers? I'm going to add them together. So I have 1 over 3 plus, you guys with me? 1 over 4 plus 1 over what? 5. Before I can add these together, I have to get a common denominator. What's going to be a common denominator between 3, 4, and 5? What number? $60? Will 60 work? What's 5 times 4? Times 3? All right, 60 will work. And then if we can simplify it, we will. So if I want to make a 3 into a 60, what do I have to multiply 3 by? If I multiply the bottom by 20, then I multiply the top by 20. Yeah? Okay. So then I want to make 4 into 60. I'd have to multiply by 15. So 1 times 15. And then to make the bottom 60 for this last one, what 5 times what's going to give me 60? 12. So multiply the top by 12. So when I add all of these together, what's 20 plus 15 plus 12? So 47 over 60. That is your sum. Questions? All right, C and D are a little bit different. They're not meant to be tricky or anything like that. They just want you to be aware. C. Letter C, first of all, wants me to start using what number? 5, and end using what number? So 5, 6, 7, 8, 9, and 10, yeah? When I plug in 5 for K, what do I get? 5, okay? So I plug in 5, I get 5. When I plug in 6, what do I get? When I plug in 7, what do I get? When I plug in 8, what do I get? When I plug in 9, what do I get? When I plug in 10, what do I get? What do I do with all those? Add them up. What is 5 plus 6 plus 7 plus 8 plus 9 plus 10? What is it? 45? Okay, thank you, ma'am. Now, no matter what this expression is, guys, that's the expression used. It doesn't matter if they have a K, an I, a J, an N. It does not matter. Whatever that expression is, you start with the bottom number plugging in, you end with the top number plugging in, and you add them all together. So now we look at D, and you're like, well, wait a second. Is there a variable for you to plug into? No. So what is the number every single time? When you try to plug in 1, what is your number that you get? 2. When you try and plug in 2, what's the number you get? 2. When you plug in 3, what do you get? 2. You're not adding all the 2's together because it's not that you're plugging in 2 each time. So you'll have a question on WebAssign that looks like this, and you have to put in answers like this. No matter how many boxes there are, whatever that number is out here, if there's no variable with it, it's just that number in every single box. Does that make sense? That's it. So if you guys had something like this, if you had, let's do one more example. Say you had, I'm terrible at drawing this. That's not right, but whatever. Okay, so we have n equals 3. And I want to stop at, I don't know, 7. Right? We're going to learn 2 different formulas, whether it be geometric or arithmetic, to where you don't have to evaluate with each one. Because what if I made that bottom number 2 and the top number 19,000? Would you guys start at 2 and go all the way from 2 to 19,000 and then add all the numbers together? No, it would take you forever. So when you have little basic ones like this, and you know your expression is 2n squared minus 5, right? This is not arithmetic or geometric because it's squared. And again, you'll understand this more when we start talking about the other 2. But if you have an arithmetic or a geometric, there is a specific formula that you'll use that you don't have to plug in every single one and then add them together. In this case, there's the only thing we can do. So I'm going to start evaluating with 3, and I'm going to stop evaluating at what number? 7. So 3, I'm going to plug in 4, 5, 6, and 7. So if you were going to find the summation of this, I need to see 2. What's the first number I'm plugging in? Good. So squared minus 5. And tell me what that is. What are we going to do first? Do we multiply first? Do we subtract? Do we square? What do we do? Square. So 3 squared is 9. 9 times 2 is 18. And 18 minus 5 is? Good job. I need to see that work, guys. I need to see you evaluate, plugging in and evaluating. So next, I'm going to plug in what number? 4, okay? These numbers are going to get bigger in a hurry, and that's okay. But we're going to square first. What is 4 squared? 16 times 2 is 32. Good. Minus 5 is 27. Perfect. So now we're going to get a little bigger. I'm going to plug in 5. So 2 times 5 squared. Minus 5. Square 5 first. 5 squared is 25. Times 2 is 50. Minus 5 is 45. Perfect. Questions? All right, let's plug in 6 then. 2 times 6 squared minus 5. 6 squared is 36. Times 2 is 72. Minus 5. 67. Okay. And then lastly, ladies and gents, I'm going to stop with 7. So 2 times 7 squared minus 5. 7 squared is 49 times 2, 98. Good. Minus 5. How much? Okay, 93. Now, what do I do with all of these numbers? Add them up. So 13 plus 27 plus 45 plus 67 plus 93. A couple of you do it. 245? Okay, 245. That is your answer to that question. Questions? All right. That is it, ladies and gents.